Next example of linear combination. Let V1 is 1, 2, 3, V2 is 0, minus 1, 2. The vectors in R3 show that this vector minus 1, minus 4, 1 is a linear combination of V1, V2. We have to express this vector as a linear combination of these two vectors. So previous problems, these problems are what? We have to express the vector of R3, one vector of R3 as a linear combination of three vectors. So here we have to express this vector of R3 as a linear combination of these two vectors. And this vector is again a vector of R3 is not linear combination of V1, V2, V3. So two problems. One is of linear combination and one is of not linear combination. So in order to express this vector as suppose U bar and these two vectors are V1, V2. So take two scalars K1 and K2 be scalars such that U bar is equal to K1 V1 plus K2 V2. U bar is what? 1 minus 4 minus 1 minus 1 minus 4 1 is equal to K1 V1 is 1 2 3 V2 is 0 minus 1 2. So we have to express this vector suppose U bar as a linear combination of V1 and V2, means we have to find the two scalars K1 K2. Let K1 K2 be scalars so that U bar is equal to K1 V1 plus K2 V2. Suppose if I have to express the one vector as a linear combination of three vectors, then take three scalars K1 K2 K3 be scalars so that U bar is equal to K1 V1 plus K2 V2. Plus K3 V3. If you have to express suppose single vector as a linear combination of four vectors, then what is your first sentence? Let K1 K2 K3 K4 be scalars such that U bar is equal to K1 V1 plus K2 V2 plus K3 V3 plus K4 V4. So if I have to express single vector as a linear combination of two vectors, then take two scalars. So first sentence is what? Let K1 and K2 be scalars such that U bar is equal to K1 V1 plus K2 V2. Okay, and if I have to express single vector, one vector as a linear combination of three vectors, then your first sentence is what? Let K1 K2 K3 be scalars so that U bar is equal to K1 V1 plus K2 V2 plus K3 V3, like this. So if we have to express three vectors, one vector as a linear combination of three vectors, then what is your first sentence? Let K1 K2 K3 be scalars such that U bar is equal to K1 V1 plus K2 V2 plus K3 V2. So here we have to express the one vector as a linear combination of two vectors. So first sentence is U bar as the given vector, V1 bar, V2 bar as these two vectors, and then let K1 and K2 be scalars so that U bar is equal to K1 V1 plus K2 V2. Then substitute the value of U bar, V1 and V2. Then apply the definition of scalar multiplication in R3. That is, we have this, and then definition of addition of two vector. We have this. Okay, K1 plus 0, then 2K2, 2K1 plus not plus minus K2, and 3K1 plus 2K2. And then comparing the LHS and RHS, we have K1 is minus 1, 2K1 minus K2 is minus 4, and 3K1 plus 2K2 is equal to 1. So we have this is the system. Now we have to solve this system and we have to find the values of K1 and K2. So there are three equations and two unknowns. So out of these three equations, solve any two equations and find the values of K1 and K2. And if that two values of K1 and K2 satisfies the remaining equation, then we say that this system is consistent. Or directly we write the augmented matrix and express and convert that matrix to echelon form. Okay, so the first is what? So we will solve the first two equations. So K1 is minus 1 and the second equation gives K2 is 2. After substituting K1 is minus 1. And this equation, if we substitute these values of K1 and K2 in the third equation, then which satisfies all the three above equations, that is this satisfies the third equation. And therefore, these are the values of K1 and K2. If these values of K1 and K2 does not satisfy the remaining equation, third equation, then we say that the system is inconsistent. So this is the way to solve this equation, this system, because this system contains three equations and two unknowns are 2. So solve any two equation, and if that values of K1 and K2 satisfies the remaining equation, then we say the system is consistent. This is one method, but another method is what? We can solve this system by using Gauss elimination method. That is the right the augmented matrix and convert the matrix to echelon form. So, and if the rank of A is equal to rank of AB, then we say the system is consistent. And then find the values of K1 and K2 by rewriting the equations. But then we have these values of K1 and K2, and by substituting these values of K1 and K2, we have U bar as a 1 minus 1 minus 4 1 as expressed as a K1 is minus 1 V1 plus K2 as 2 V2. That is, U bar is a linear combination of V1 and V2. Okay, these coefficients are minus 1 and 2, K1 and K2. So we can solve this system by using Gauss elimination method. That is, write the augmented matrix. So coefficient of K1 is 1, coefficient of K2 is 0, and the constant coefficient is 4. Yes, in this problem. So we can solve this problem also by using this method, that is form the augmented. This is the method to solve this system. So same, here is the three equations and two unknowns. So I have to solve this system by using either Gauss elimination method or this method, that is find the values of K1 and K2, and if this equation does not satisfy the third equation, then we say the system is inconsistent. Or we can write the augmented matrix and convert the matrix to echelon form. So what we have, 0 is equal to 1, which is absurd. So if we solve this system by using this method, that is Gauss elimination method, then last equation is 0 is equal to 0, which is true, which is not absurd, which is not impossible. 0 is equal to 0 for this system. So try to solve this system by using Gauss elimination method, that is form the augmented matrix. What is the augmented matrix? 1 0 0 1 0, not only we have 1, coefficient of K1 is 1, coefficient of K2 is 0, is equal to minus 1. Means in first row of the augmented matrix is what? 1 0 minus 1. Then second row is 2 minus 1 minus 4. The third row is 3 2 and 1, like this. We have the matrix are like this, 3 by 3 order. And then reduce the matrix to echelon form. We have K1 is minus 1 and K2 is 0, and the last equation is 0 is equal to 0, like this. We have the last equation 0 is equal to 0. We have this as 0 is equal to 0. Okay, so solve the system by using this method or by using the Gauss elimination method. So in the second problem, we denote this 4 7 15 as U bar, and now we have to show U bar is not linear combination of V1 and V2. We will try to express U bar as a linear combination of V1 and V2. So first sentence is, let K1 and K2 be scalar such that U bar is equal to K1 V1 plus K2 V2. Then substitute U bar as 4 7 15, substitute V1 as 1 2 3, V2 as 0 minus 1 2, this V1 and V2. And then apply the method of scalar multiplication and addition of two vectors. We have this. Okay, and then compare the LHS and RHS. We have the system K1 is equal to 4 minus 2K2, 2K2 minus 2K2. It is not minus 2K2, right? Just 2K2, 2K1. It is not minus 2K1. It is 2K1 minus K2 is equal to 7. And the third equation is what? 3K1 plus 2K2 is equal to 15. Is equal to 15. So this is the system. So this system has two unknowns and three equations. So out of these three equations, solve any two equations. Suppose we will solve the first two equations. So we have K1 is 4, and after substituting K1 as 4, so it is K2 is 1. So we have K2 is 1. But if we substitute these values of K1 as 4 and K2 as 1, so what do we have? 3 into 4 is 12 plus 2 into 1 is 2. So that is, we have 14 answer. But 14 is not equal to 50. So these K1 and K2 do not satisfy the third equation of this system. And hence the system is inconsistent. So this is the way to solve this system, that solve any two equation. When this method is applicable, if the equations are 3 and unknowns are 2, that is the number of equations is greater than the number of unknowns, then we have to apply this system. Or instead of this, we can apply the Gauss elimination method. That is, write the matrix of augmented matrix. So 1, K1 coefficient of 1 is K1 is 1, K2 is 0 is equal to 4, then 2 minus 1 7, and then 3 to 50. So this is the augmented matrix. So write here line, dotted line, or straight line here. So this matrix is the matrix of coefficient A matrix, and this is the matrix B, that is this column matrix 4 7 15, and the combination of this A and B is the augmented matrix AB. This is the matrix AB, and now we have to reduce this matrix to echelon form. So here is 1, so we have to reduce this 2 and 3 to 0. So the operation are R2 minus 2 R1 and R3 minus 3 R1. So we have this matrix. First row as it is, second row we have 0, then minus 1, and minus 8 plus 7 is minus 1, then 0 0 2, and then minus 12 plus 15 is 3. Then we have to reduce this minus 1 to 1. So minus 1 R2, we have 1 1 at this place, and then we have to reduce this 2 to 0. So apply the operation R2 R3 minus 3 2 R2 2 R2. Then by using this 1, we have to reduce this 2 to 0. So we have the 0 at this place, and this minus 2 into 1 is minus 2, plus 3 is plus 1. And then rewrite the equation. So what we have, K1 is equal to K1 plus 0 into K2 is equal to 4, means K1 is equal to 4. Then second equation, 0 into K1 means 0, plus 1 into K2 means K2 is equal to 1. And the third equation, 0 into K1 is 0, 0 into K2 is 0. So 0 is equal to 1, and which is absurd, which is impossible, and therefore the system is inconsistent. This is the one way. Or we can write, use the concept that rank of A and rank of AB are equal or not equal. So what is the rank of A? This after cancelling this last column, the remaining matrix is the echelon form of the matrix A, matrix of coefficient. And so how many non-zero rows in this matrix? This is non-zero row, this second is non-zero row, third is zero row. So up to this, after cancelling last column, the remaining is the echelon form of the matrix A. And so from which the rank of A becomes 2, because we have 2 non-zero rows in the echelon form of the matrix A. And rank of this whole matrix is the echelon form of the matrix AB. And it contains 3 non-zero rows. This is non-zero row, this is non-zero row, this is non-zero row. And so rank of AB is 3. And so rank of A is not equal to rank of AB, and therefore system is inconsistent. So in 3 ways we can say the, so instead of this, that finding the value of K1 and K2 and it satisfies the third equation, to solve the system, we use only the Gauss elimination method. In every problem, don't use like this method, So in order to solve the system, we use the Gauss elimination method. And what is the Gauss elimination method? Write the augmented matrix, convert the matrix to echelon form, and write the rank of A and rank of AB. And if rank of A and rank of AB are equal, then we say the system is inconsistent. And then after rewriting the equation, we have the solution of the system. But if the rank of A is not equal to rank of AB, then we say the system is inconsistent. So no need to find the values of the unknowns K1, K2, K3, K4, whatever may be there. So if the rank of A and rank of AB are not equal, means the system is inconsistent, mean the values of K1, K2, K3, K4, whatever may be the equation contains does not exist. We say that K1 and K2 does not exist in the system is consistent. So if the system contains 3 unknowns, suppose K1, K2, K3, then we say that K1, K2, K3 does not exist, or K1, K2, K3, K4 does not exist. So in further topics, or in this topic, don't use like this method, or here is this method, that solving 2 equations and then satisfying the third equation. Instead of this, in every problem, if you have to solve the system, then just use the Gauss elimination method. That is, what is the Gauss elimination method? Form the augmented matrix and reduce the matrix to echelon form. Write the rank of A and rank of AB. If both are equal, then we say the system is consistent. and then after from the echelon form we rewrite the equation and find the values of unknowns. And if the rank of A is not equal to rank of AB, then the system is consistent. If we apply the same method to this problem, then we have the rank of A is 2, rank of AB is also 2, and also system is consistent. And after rewriting, we have K1 is minus 1 and K2 is 2. So if the system has either two equations, three equations, two unknowns, three unknowns, four unknowns, whatever may be the system, we have to use the Gauss elimination method to solve the system. So if the system is any system, if I have to solve the system, don't use any another method, just use the Gauss elimination method. So after rewriting, the system is consistent, we have the solution, and after rewriting the equations. But if the system is inconsistent, then say that the values of unknowns does not exist, and therefore u bar is not linear combination of v1 and v2. We does not have the values of k1 and k2 which satisfies this equation number 1, and therefore u bar is not linear combination of v1 and v2. So these are the two problems. In first problem, u bar is a linear combination of v1 and v2. In the second problem, u bar is not linear combination of v1 and v2. So learn from these two examples, we learn that when one vector is a linear combination of the remaining 2 or 3, and when one vector is not linear combination of the remaining 1 or 2 or 3. Okay. So next example is again v1 is this, v2 is this. The vectors in R2 show that every vector of R2 is a linear combination of v1 and v2. So if we take AB as arbitrary vector in R2, then we can express AB as AB is equal to A10 plus B01. And therefore, every vector of R2 is expressed as a linear combination of these two vectors 10 and 01. This another notation for this 10 and 01 is E1 bar, E2 bar. So similar to R3, for R3 111 100 100 010 and 001 are these are the three vectors E1 E2 E3. Then every vector is a linear combination of E1 E2 E3. So this is the first problem of our last lecture, that this if we denote E1 as 100, E2 as 010 and 001. So every vector of R3 is expressed as a linear combination of E1, E2, E3. And we say that therefore LS, if S is the set contains three vectors E1, E2, E3, then LS is equal to R3. Or we say that S spans R3, or R3 spanned by S. Okay. So in this case, in R2, these two vectors, the set contains these two vectors 10 and 01, 10 and 01. If we denote the set contains 10 and 01 by S, then we say that LS is equal to R square. LS is equal to R square. If we denote this vector 10 and 01 by suppose V1 and V2, and if we write capital S is equal to set V1 comma V2, then LS is equal to R2. That is, these two elements, or the set of these two elements, spans R2. So these two vectors spans R2. We said in another word, these two vectors spans R2. So why? Because every vector of R2 is expressed as a linear combination of these two vectors. So which shows that AB is a linear combination of 10 and 01. And hence every vector of R2, because this AB is an arbitrary vector, and it expressed as a linear combination of these two vectors, means every vector in R2 is a linear combination of 10 and 01. And therefore these two vectors spans R2, or this, if you denote S as the set of these two vectors, then this set spans R2. Similarly, the next problem is what? U bar is 111, V bar is 110, and W bar is 100. These are the three vectors in R3. Show that 3, 2, 1 is a linear combination of U bar, V bar, and W bar. So this is the particular vector. We have to express this vector as a linear combination of these three vectors. So let first sentence is what? Let K1, K2, K3 be scalar such that Q bar is equal to K1 V1 plus K2 V2 plus K3 V2. So write this first sentence. that u bar, v bar, w bar are the notations. So first sentence is denote this 3 to 1 by u bar, and then we u bar is already here is the notation for 111. So denote this 3 to 1 by suppose w bar, x bar, and then we write that x bar, let k1 k2 k3 be scalar such that this x bar is equal to u bar plus v bar, u bar k1 u1 k1 u bar plus k2 v bar plus k3 v bar. So right, this is denote this 3 to 1 by another notation, another that suppose v bar is the v1 bar is the notation for 3 to 1. Then the first sentence is what, let k1 k2 k3 be scalar such that v1 bar is equal to k1 u bar plus k2 u bar k2 v bar plus k3 v bar. So write that first sentence, and then substitute the values of v1 bar as 3 to 1 is equal to k1 u bar plus k2 v bar plus k3 v bar. So write the first sentence that let k1 k2 k3 be scalar such that 3 to 1 is equal to k1 into u bar plus k2 into v bar plus k3 into w bar, and then substitute the values, and then write apply the method of definition of scalar multiplication and vector addition. We have the first step as k1 comma k1 comma k1, then k2 comma k2 0, and then k3 comma 0 0, and then apply the addition definition. So k1 plus k2 plus k3 comma k1 plus k2 comma k1, so dot k1 k3, then k1 plus k2, and the last is k1 plus 0 plus 0. Okay, this is k1 is right. So this is by using the definition of scalar multiplication and addition in R3, usual addition and usual scalar multiplication in R3. Then equating LHS and RHS, we have k1 plus k2 plus k3 is equal to 3, k1 plus k2 is equal to 2, and k1 is equal to 1. So we have to find the values of k1, k2, k3. So we can apply the Gauss elimination method, or directly we have the values of k1 as 1. Substitute in the above equation, we have k2 is again 1, and substitute these values in above equation, we have k3 is equal to 1. So already this is a matrix, augmented matrix is in the echelon form. So no need to apply the Gauss elimination method, that is we have to form the augmented matrix and reduce the matrix to echelon form. Already the augmented matrix is in the echelon form, and therefore we have the directly solution, and therefore we have the values of k1 k2 k3. This system is consistent, and we have the values of k1 k2 k3. So 3 to 1 is expressed as 3 to 1, write k1 as 1, k2 as 1, and k3 as 1. So this last equation shows that 3 to 1 is expressed as a linear combination of these three vectors 1 1 1, 1 1 0, and 1 0 0. So in this method, this problem is also we can solve in another way. We write the problem that show that every vector of R3 is a linear combination of u bar, v bar, w bar. So we can show that every vector of R3 is a linear combination of u bar, v bar, and w bar. So how we can show this problem, answer of this problem? So take ABC as any vector of R3. Suppose ABC as any vector of R3, and denote that v1 bar, and then we write the first sentence that let k1 k2 k3 be scalar such that ABC is equal to k1 1 1 1 plus k2 1 1 0 plus k3 1 0 0, and then write apply the definition of scalar multiplication and vector addition. We have the equation k1 plus k2 plus k3 is equal to a, k1 plus k2 is equal to b, and k1 is equal to c. So after k1 is equal to c, substituting the above equation, we have k2 is 2 b minus c, and we have the similarly k1 as a minus b minus c, or another value. So that is substitute k1 as c in the above equation, we have value of k2, and that values of k1 and k2 in the above equation, we have k2 and k value of k3. Okay, so substitute that values, so that ABC is equal to write k1 into 1 1 1 plus k2 like value of k2 1 1 0, and k3 value of k3 1 0 0, and then we say that every vector of R3 is expressed as a linear combination of u bar, v bar, and w bar, and therefore we say that this set uh, of these three vectors u bar, v bar, w bar spans R3. If we denote the set S by capital S by u bar, comma v bar, comma w bar, that is these three vectors, then that set spans R3. How we can write this in the equation form? Write L in round bracket S, capital S, is equal to R3. Ls is equal to R3. So similar to the set 1 1 0, 0 1 0, and 0 0 1. This set, another set 1 1 1, comma 1 1 0, and 1 0 0 also spans R3, because every vector of R3 is expressed as a linear combination of these three vectors. So these are the problems for homework. So determine which of the following are linear combination of these two. So where to solve this example, where to express this as a linear combination of these two vectors. If it is expressed as a linear combination, we say the answer is yes. Otherwise we say the vector is not linear combination of these two vectors. So similarly, these are the problems. Yeah, in this 7 number problem, we have to express this vector as a linear combination of these three vectors. This three vector as a linear combination of these three vectors. So in the last example, 8 number example, we have to express this polynomial as a linear combination of these two vectors. We have to express this polynomial as a linear. Suppose this is Q. We have to express Q as linear combination of P1 and P2. So what is the sentence for these three problems? First sentence: let K1 and K2 be scalar such that this Q is equal to K1 P1 plus K2 P2, and that value, find the values of K1 and K2. If the values of K1 and K2 does not exist, that is the system is inconsistent, then we say the vector Q is not linear combination of P1 and P2. Okay, so this is X, and these are the ABC, three vectors, three elements of the M2 by 2R. X is also the element of M2 by 2R, and where to express this X as the linear combination of these three vectors. So what is your first sentence of answer of this 9 number problem? Let K1, K2, K3 be scalars, small k1, small k2, small k3 be scalars such that X is equal to K1A plus K2B plus K3C. And then write the values of X, capital X, capital A, capital B, capital C, and then apply the definition of scalar multiplication in M2 by 2R. That is, multiply by K1 to each element, K2 by 2 with each element, K3 by 2 each element, and then add the three vectors, that is Ka plus Kb plus Kc. That is, apply the definition of addition. We get, and then compare the LHS and RHS. We get the 4 equations. Okay, and unknowns are 3. Then we have to solve that system by using Gauss elimination method. We have the values of K1, K2, K3. If and we have to apply the Gauss elimination method. That is, first write the augmented matrix and convert the matrix to echelon form, and then write the rank of A and rank of AB, and if they are equal, then find the values of K1 and K2, K3, and then substitute. We say that this is the linear combination of these three vectors. So solve these all problems. Which of the following vector is linear combination of these two vectors? Justify your answer. Same problems. Where to express these vectors as a linear combination of U, V, W, if they are expressed as a linear combination. So similarly, P1 and P2 are two polynomials of degree 2. So these are the two members of the P2, and this is the where to express these polynomials as the linear combination of these two vectors if possible. So which of the following matrices are linear combination of these three vectors ABC? So this is the problem. We have to express this as a linear combination of ABC. Denote this vector as this element as X. So write the first sentence. Let K1, K2, K3 be scalar such that X is equal to Ka1 plus K1A plus K2B plus K3C, and substitute the values. Find the values of K1, K2, K3 if they exist. So these are the answers of these problems. All these problems 1, 2, 3. So 1, this is 2, and this is 3, 4. So these are the answers. If they are expressible as a linear combination, then the coefficients K1 and K2, values of K1 and K2 are given. So 0, 0, 0. Observe this example, 0, 0, 0. So this vector is expressible as linear combination of any three vectors, any two vectors. So just take k1 as 0 into this u bar plus 0 into v bar plus 0 into w bar. So 0, 0, 0 expressed in the form 0 into u bar plus 0 into v bar plus 0 into w bar. So no need to find the any calculation. We directly say k1 is 0, k2 is 0, k3 is 0. 0, 0 vector. So in R3, if S is set E1, E2, E3, E1 is 1, 0, 0, E2 is 0, 1, 0, and E3 is 0, 0, 1, then every vector of R3 is expressible as a linear combination of E1, E2, E3, and therefore we say LS is equal to R3. So this set 1 x square x raised to n span R3. This set contains, if we form the set of all these polynomials 1 x square x raised to n, then these are n plus 1 in number. These are n plus 1 in number. Like this, there are three vectors in this set. N plus 1 vectors are there. So spans. So solve all these exercises. Same problem. Here is the, if you observe this problem, P1, P2, P3 are given, and we have to express this polynomial as a linear combination of P1, P2, P3. So what is your sentence? Let K1, K2, K3 be scalar such that, suppose this is Q bar, Q, then we say Q is equal to K1, P1 plus K2, P2 plus K3, P3. So solve all these examples. 0, 0 is the 0 polynomial. So this 0 polynomial expressed as 0. Suppose this is Q. Q like this. Q is this. So Q is this 0. So we can write 0 is equal to 0 into P1 plus 0 into P2 plus 0 into P3. So this is 0 polynomial. Okay. So it expressed in the form 0 into P1 plus 0 into P2 plus 0 into P3. So these are the problems on the matrix. So solve all these problems. Answers are given. Answer of some problems are given. So solve all these problems. This is about the topic linear combination. And in the next lecture, we will see spanning or linear span, definition of linear span, and the set spans vector space. So in the next lecture.